everyone. We are in week 1 of the first quarter of this school year. I hope you will learn something from our lesson today. So, lesson 1.1, the introduction to sequence. At the end of the lesson, you will be able to define a sequence, differentiate finite and infinite sequence. Write the next few terms of a sequence. Our brain loves predicting. The brain seeks meaning by organizing words, numbers, and ideas into meaningful patterns. It means that we always find a pattern. We are very observant. Us humans naturally look for the pattern and want to fill in the missing pieces, just like solving a jigsaw puzzle. Many professions that use mathematics are interested in one specific aspect, finding patterns and being able to predict the future. So let's have some example. Predicting the COVID-19 cases in the Philippines. This chart shows the active cases, number of deaths, and total COVID-19 cases in the Philippines. They are all in increasing trend, and it could be predicted that if the factors affecting these cases like the healthcare system, quarantine strategies, contact tracing, testing capacity, and people's discipline are constant, then the future number of cases will rise. So let's do our part. Let's be disciplined. Let's stay at home, stay healthy. Okay? Another example is predicting the stock market value. Stock market actually determines the economic status of a country. For example, here in the Philippines. Bankers also look at historical data of the stock prices, interest rates, and currency exchange rates to estimate how financial markets might change in the future. Because being able to predict if the value of a stock will go up or down can produce more profit. The graph shows that the stock market value rises and falls. And by observing the trend, it can be predicted that the stock market value will fall due to the pandemic. That's why it's not advisable to invest much as of now. You may invest later part of this year because next year, the new normal, probably it will go up again. Many professional mathematicians use highly complex algorithms to find and analyze all these patterns. But we are going to start with something a bit more basic. So that is about sequence. Because when we say sequence, it is an ordered list of numbers or other elements like geometric objects that often follow a specific pattern or function. Observe the pattern in this figure. Having circle, the green circle, next is a blue diamond, followed by a blue diamond again. Next is a green circle, blue diamond, green circle. So by observing the pattern, what will be the next figure? Correct, it's a blue diamond. Next one. We have here a dot, and on the next figures, we have a triangle. Observe how the triangle was formed using the dot. If we have one dot, there is no triangle yet. If we have 3 dots, we can form a triangle. But in the next figure, you will observe that we still have one triangle despite the fact that we added 3 dots from the previous triangle. And on this 4th figure, still one triangle, but we added 4 dots from the previous triangle. So can you guess what will be the next figure? Knowing that this triangle formed was wherein you added only 2 dots from the previous figure. In here, you just put 3 dots from the previous triangle, and so with this one. So again, what is the next figure? Got it. It is still a triangle, but this time it is made up of 15 dots. Okay? So this is actually called the triangular numbers. So when we say triangular numbers, this is the figure that we are referring to. So the number of dots that we have there is actually 1, 3, 6, 10, 15, and 21, and so on. Next one. This one shows a pattern of the width of a square. So on the first square, this innermost square, the width of the square is 1 unit. This is the next square with a unit of with the width of 1 unit also. But this square, the third square, has a width of 2 units. This is the next square, which is 3 units in width. Then followed by this bigger square. And biggest square for this case. So the width of the square is 5, correct? Now, did you observe a pattern on how the width of the previous square related to the next square? Can you guess the width of the next square? Correct. The width of the next square is 8. How is that? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Meaning we only add the previous 2 terms to get the next term. And that is actually a Fibonacci sequence or a Fibonacci numbers. So the numbers there are 1, 1, 2, 3, 5, 8, 13, and so on. Again, a Fibonacci sequence or numbers is formed by adding the previous 2 terms of a sequence. We call every element or every individual in a sequence as term. There are different forms of sequence when it comes to number of terms. We have a finite sequence. It means it contains fixed number of terms, meaning limited number of terms, wherein we can actually count how many terms are there. So for instance, we have 1, 5, 9, 13, 17. This sequence starts at 1 and it stops at 17. Therefore, it's a finite sequence. Another example is the 3, 6, 12, 24, and 48. It starts with 3 and it stops at 48. If you will count it, there are 5 terms in the sequence. So the fact that we can count how many terms we have in that sequence tells us that the sequence is a finite sequence. An infinite sequence, on the other hand, is the form of sequence wherein you have infinite number of terms, countless, meaning you cannot count it, it's limitless, it's continuous, because it starts but it does not stop. Example, we have 1, 5, 9, 13, 15, 21, and so on. It starts at 1 but ended with the 3 dots, which is ellipsis. It tells us and so on. So therefore, it does not end. We're not sure when will it stop. Therefore, it is an infinite sequence. Just like this one. 3, 6, 12, 24, and so on. This ellipsis tells you that from 3, your sequence will continue. Okay? So this one is an infinite sequence. Let's try this. State whether the given sequence is infinite or finite. The sequence 3, 5, 7, and so on. Yes, correct. This is an infinite sequence because it starts at 3, but it does not end. Next, 1, 2, 3, 4. How many terms? Yes, 4 terms. Therefore, you were able to count how many terms there are in the given sequence. Therefore, this is a finite sequence. This one, ellipsis, -3, -2, -1, 0, 1, 2. Is it infinite or finite? It starts at ellipsis. What is that in particular? What particular number is this? Can you tell? No, we can't tell what particular number this sequence started. Therefore, even though we know that it stops at 2, still this one is an infinite sequence. Next, 20, 30, 40, 50, and so on until 200. It starts at 20, continues, but it ends at 200. Therefore, this one is a finite sequence. I hope you're getting it right. Okay. Number 5, 7, 14, 21, and so on until 2401. Correct. This is a finite sequence. Is that clear? I hope so. Let's complete the following sequences. 1, 4, 7, 10. Can you observe a pattern that happens from one term to the next term so that we will be able to fill in these 3 blanks? Okay. So from observation, you can see that the gap between the 2 consecutive terms here is 3. In here, it's also +3. So with this, that means to get the next term, we need to add 3 from 10. And that will give you 13. Then 13 plus 3 will give you 16, and 16 plus 3 will give you 19. Therefore, 13, 16, and 19 are the 3 unknown terms. Next, 46, 43, 40, 37 with or followed with 3 blanks. What are the values of the terms here? Observe again the pattern. Okay, so the difference between 2 consecutive terms is -3. So with this and here. Therefore, I'll just have to subtract 3 from 37. And that will give me 34. And from 34, I will subtract 3 again to get 31. And then the last term is 28. So the unknown terms are 34, 31, 28. Next, 3, 6, 12, 24 with the 3 blanks there. Observe the pattern. Correct. Every term is double of its previous term. So just multiply 3 by 2 to get 6, multiply 6 by 2 to get 12, multiply 12 by 2 to get 24. So 24 times 2 is 48, and 48 times 2 is 96, and 96 times 2 is 192. Therefore, the 3 unknown terms are 48, 96, and 192. Did you understand? Okay. Let's have this example. A, C, E, G, blank, blank, blank. Observe again the pattern. So this one, A, from A, the next term is C. So therefore, there is a gap of B. Next, from C to E, there is a gap of D. From E to G, the gap is F. From this one to this one, what should be the gap? Okay, observe A, B, C, D, E, F, G, H. Therefore, here is I. Then J, there is K. Then L, and then M. So, the three unknown terms are I, K, M. Okay? Next. 1, negative 4, 9, negative 16, blank, blank, blank. Observe the pattern. Okay, so if you will observe, this one could be equal to 1 squared. And if you will use the same pattern here, it will be the second position. 4 is in the second position, so it's negative 2 squared. Why negative and not positive? Because when you look at the pattern of the signs, it's alternating signs. Therefore, from positive here, it should be negative here. Okay? Then followed by positive and then negative. So that is 3 squared. This one is negative 4 squared. Note that the negative sign is not into the parentheses. So it is only 4 that you are squaring, not the negative one. Okay? Therefore, in here, it's 1, 2, 3, 4. Here is 5 squared. Then that is 25. Next is 6 squared with a negative sign. Gives you negative 36. 7 squared with a positive sign. That is 49. So the three unknown terms are 25, negative 36, and 49. Okay, that would be all for our lesson 1.1. Stay safe and God bless everyone. Thank you.